Hi there, this is Johnny with the Pathmind team, and in this video I will demonstrate how a simulation team at Accenture used Pathmind to solve a complex product delivery problem, saving them time, effort, and money. Accenture's product delivery problem is centered around moving products between factories, shown here in red, and distribution centers, shown here in green. This is straightforward with a single factory and single distribution center, but as Accenture wanted to tackle this problem with a network of distribution centers and required different products at different times, they needed the ability to simulate the problem. To add real-world complexity, Accenture built a simulation with a network of factories and distribution centers on a GIS map, and added variable needs for each distribution center. They used AnyLogic, the software you see on my screen, to add this complexity and track important indicators such as the delivery time to each distributor. Accenture used their AnyLogic model to compare the performance of different heuristics. A heuristic is just a logical guess or a decision strategy. But as the simulation model became more complex and realistic, Accenture could not decrease wait times below a certain point with any heuristic. So they tried Pathmind. Pathmind is a powerful tool that uses reinforcement learning algorithms to solve sequential decision problems. The idea behind reinforcement learning is simple. A policy is given a decision to make. When the policy makes the correct decision, it gets a reward. Over many simulation runs, the policy is trained to behave better and better, even in the face of complex, variable environments like the product delivery model. So, how did Accenture implement reinforcement learning with Pathmind? First, they simply added the Pathmind palette item into their existing AnyLogic model. Then, they linked Pathmind to the simulation model with a bit of code. This code defines what decision is made by the reinforcement learning policy and what outcomes are desirable. In Accenture's case, the policy decides how much of each product and from which factory each distributor should order. Desired behavior for Accenture is reflected in low delivery times. They want to minimize the waiting. After adapting their model, Accenture trained an intelligent policy in the cloud. This training is made simple in the Pathmind web app, which you see here. The performance of a given policy can be clearly tracked by user-defined metrics, such as the delivery time in Accenture's case, that you see here. This plot down here shows the policy performance or reward as the training progresses over many simulation runs. As you can see, the policy learns desirable behavior, which is reflected in the delivery time metric as well. Training in the web app gives you the flexibility to run numerous training programs in parallel, and then to compare results and cherry-pick a top performer. After training is complete, any one of your policies can be downloaded and tested in AnyLogic so you can compare against the heuristics. Here's a Monte Carlo simulation that compares the performance of 3 decision-making strategies: actions chosen at random, the Accenture heuristic, and the Pathmind policy. Note that the X scales are different for each one of these histograms, so their means are also plotted over here for comparison. Random actions gives an average waiting time of 90 hours. The Accenture heuristic gives an average waiting time of 45 hours, and the Pathmind policy is all the way down at around 9.5 hours. Pathmind cut Accenture's factory distributor delivery time to 1/5 of their baseline. If you have a problem that involves making sequential decisions in the face of variability, Pathmind can help you increase performance. For more information on this and other tutorials, please follow the links in the description.